this is a good time to do a summary of what we have learned in this section. In particular, I want to show you a diagram of the application architecture that we are using to work with Firestore in our project. And as you can see here, we have Firestore at the top, and this is our remote database, and we can use this to store some state, such as the list of jobs that our user has created. And in order to read and write data to Firestore, we have created a Firestore service class. And this works with key value pairs that represent the fields in our Firestore documents. Then we have our Firestore database class, and you can think of this as the application-facing API to Firestore. And it looks like this. So this class works with data models such as the job model that we have created, and we will add more data models in the future. And finally, we have the widgets in the UI layer, and these are used to generate data that can be written to Firestore and read data that we can show on screen. And every time we need to write something, we can use an API that is based on a feature, because writing data to Firestore is an asynchronous operation. And every time we need to read something, we can use an API that is based on streams. And this is because Firestore is a real-time database, and we can design a real-time application on top of it. And the way to do that is to use streams and stream builder. By the way, I want to clarify something about the way I have been naming these classes. And that is that some people use the word repository to talk about a class that can be used to access data on the backend. Meanwhile, in this course, I've talked about a Firestore service and a Firestore database. So whether you want to call this a Firestore service or a Firestore repository, it's up to you. In any case, the important thing to keep in mind is that we can separate Firestore database and Firestore service into two classes, so that all the Firestore specific code can go into the Firestore service. And this means that if in the future we want to use a different database, we can do that by simply replacing Firestore service with a different class. However, our database-facing API would be the same, so changing the database doesn't have any impact on the rest of the code. In summary, in this section we have learned about relational databases and Cloud Firestore. And we have learned what a NoSQL database is and how we can use documents and collections to structure our data in Firestore. And we have also seen how to define strongly typed data classes that represent the documents that we use in Firestore, and how we should use them, rather than exposing key value pairs in our widget classes. And finally, we have designed a simple database class that we can use to interface to Firestore. And in the coming sections, we will build upon what we have learned by adding more functionality to the database class, as well as adding more pages to our time tracking application. Okay, so let's continue on the next section.